Let me start with something slightly uncomfortable. Every single year, serious UPSC aspirants, people who are disciplined, people who are putting in 8 to 10 hours daily, they say the same thing. That is, they say environment is unpredictable, there are too many reports, too many conventions, too many terms. You never know what UPSC will ask. Now I want you to think for a moment. If thousands of serious aspirants every single year are facing the same confusion, then either UPSC is random or the preparation approach is wrong. And what I am going to show you today is that the second is true. The preparation approach is wrong. Because what looks random on the surface is actually structured underneath. Environment is not unpredictable. It only looks unpredictable because you are studying it incorrectly. You are studying environment as a subject. UPSC is asking environment as a system. Earlier, UPSC asked national parks, species, basic ecology. For that questions, memory was enough. But now, look at recent papers 2020, 21, 22, 23, 24, 25, and so on. There is a very clear shift. UPSC is asking climate finance, carbon markets, system behavior, ecological thresholds, and policy mechanisms. So the paper has moved from what exists to how the world works. And this is where most aspirants fail because they are still preparing for the old pattern. So today I am not going to increase your content because more content that equals to more confusion. Instead, I will compress environment into 5 systems. What are they? System number 1, climate governance. System number 2, carbon economy. System number 3, ecosystem stability. System number 4, pollution systems. System number 5, biodiversity strategy. This is your real syllabus. Let's begin. Climate governance. Our system number 1 is climate governance. Climate governance, let me ask you something very clearly. If climate change is such a serious problem, why has it not been solved yet? Technology exists, awareness exists, and global agreement exists. Still, emissions continue. Why? Climate change is not a science problem, it is a negotiation problem because every country agrees on the goal but disagrees on responsibility. That is the problem. Now, understand the core conflict of the climate governance. Let's take two worlds. One is developed countries and another one is developing countries. Developed countries are already industrialized early, emitted more, became rich. As far as developing countries is concerned, they're still growing, need energy, need development. So the now tension has started here. Developing countries say you polluted first. Undeveloped countries, you should pay more. But developed countries say undeveloping countries, futures future emissions matter. Everyone must contribute. This where conflict has started. This conflict is climate governance known as. Now bring the most important element is money. If India wants to shift to green energy, we need solar infrastructure, we need battery systems, we need hydrogen economy, we need grid upgrades. This costs trillions. So the real question is who pays? Who pays? Global Stocktake. What is Global Stocktake? Global Stocktake is periodic review of global progress in climate action under the Paris Agreement. Global Stocktake is not about targets. It is about checking whether we are on track or not. As far as climate governance is concerned, global stake is targets, review, finance. Finance means NCQG. So GST is accountability mechanism, global stack tech. Global stack tech every 5 years evaluates emission reductions, adaptation efforts, climate finance. Are we collectively moving towards 1.5 degrees Celsius goal? So now let's understand one important mechanism very quickly and again, that is global stock tech. This is not about setting targets, it is about checking progress. In other simple words, every 5 years the world comes together and asks one question: are we on track? Global stock tech is accountability, not ambition. It evaluates emissions, adaptation, finance, and identifies the gap. So remember this very clear. GST does not decide targets. It checks whether targets are being met or not. Here UPSC will not ask what GST is. GST matlab global stock take. It will test whether you confuse review with targets or not. So GST is means review, accountability, 5 year cycle, global, not target setting. You have to remember this in mind very much clear. Now comes the most important update for 2026, that is NCQG. Earlier the global climate finance system was based on 100 billion US dollar per year, but the system is evolving. Now it changed. This is the post 2025 climate finance architecture. And remember this clearly, this is not just a number, this is a structural shift. UPSC loves this kind of evolution, old system to new system. So if a question asks what replaced the 100 billion US dollar goal, the answer is NCQG. UPSC does not test climate finance amounts, it tests climate finance evolution. NCQG means new financial goal. It replaces what? 100 billion US dollar. This is post 2025. Developed countries lead. This is not a number change. This is the post 2025 climate finance architecture. So UPSC loves this old fixed commitment, new evolving framework. The climate system has three layers: targets, review, finance. Already we learned. Without finance, targets are meaningless. Let me discuss one UPSC trap on this NCQG. Statement 1, that is, climate finance is voluntary for all countries. Looks correct, but wrong. Developed countries is obligation. Developing countries supported. What is the trap line here? Support means not responsibility. So climate governance equal to who pays plus who acts. When the question on this came on this come in the examination, you have to do think finance, think responsibility, think developed versus developing. Here is climate money. Now once money enters, carbon becomes tradable. So what is the system number 2 that equal to carbon economy? What is carbon economy? Why it is important? Let me ask you something. If carbon is harmful, why are countries trading it? Carbon is no longer pollution. It is a priced commodity. Once something gets a price, it enters the economy. Earlier, pollution means what? Penalty. Now, emission means what? Unit. Unit means to measurable. Measurable from measurable to tradable. So, let me discuss in very deeply. Let's say example, country A reduces emission, country B does not. So country B buys credits from country A. In this context, now let's understand one powerful mechanism, that is CBAM. CBAM means carbon border adjustment mechanism. Let me simplify this. If a product is made using high emissions, it becomes cheaper. Why? So Europe says that is unfair. So now if your product emits more carbon, you pay tax at the border. This is not environmental policy, this is economic control. And remember this clearly, CBAM does not reduce emissions directly. It changes cost. And when cost changes, behavior changes automatically. UPSC is not testing climate here. It is testing trade plus carbon interaction. CBAM means what? Simply carbon tax and imports. It prevents carbon leakage, trade plus environment link, European Union policy. If your product emits more carbon, tax at border. Your location does not matter. Your carbon content matters. Let me take as far as Indian angle is concerned. No carbon market, for example, India per se. Then Europe ends. Own market, India ends. Carbon market, nothing but economic sovereignty. As far as Article 6 is concerned, some trap questions are coming in recent years. Both countries claim reduction, that is double counting, atmosphere losses. Here UPSC traps, carbon markets eliminate emissions, carbon credits remove pollution. No, they shift responsibility, not eliminate emissions. Carbon equal to measurement plus market plus control. If the question mentions in the exam that CBM credits trading, please think who benefits economically. That is most important. That is system number 3. We are moving to ecosystem stability. What is ecosystem stability? Let me ask you something. Why do disasters feel more intense now? Nature does not fail gradually, it fails suddenly. Why? Because systems operate within limits. Within limits. Threshold. What is threshold? Below the threshold level is anything stable. Beyond threshold level, it may lead to collapse. Let me take few examples, that is wet bulb theory and coral bleaching and GLOF. Let me start with something very important, that is wet bulb temperature. Now most students think this is just another temperature term, but it is not. Then what? This is not about heat, this is about survival. What is survival? Why survival? Let me explain. Normally when your body heats up, what will happen? You sweat and that sweat evaporates, then cooling your body. This is the phenomena. Now imagine a situation where humidity is very high. In that condition, sweat cannot evaporate. What will happen? So your body cannot cool itself. So it doesn't have that mechanism, that phenomena. Now combine this with high temperature. Wet bulb temperature reaches around 35 degrees Celsius. At this point, even a healthy human body cannot survive. No cooling, no recovery, no adaptation, no sweat. So no cooling. Then what will happen? This is not discomfort. This is a biological wall. So remember this clearly. Wet bulb is not about temperature. It is about the limit of human survival. Let me take another example, that is coral bleaching. Now let's move to the ocean part, that is coral bleaching. Coral bleaching. At first glance, corals look like rocks, but they are really not. They are living systems and they survive because of partnership. Inside corals, there are tiny algae. These algae provide food. Now, what happens when temperature rises? Even a small increase, like 1 or 2 degrees Celsius, the coral gets stressed and it expels the algae. Now, think very much carefully. Without algae, no food, so coral begins to starve. So, bleaching is not a color change, it is the beginning of the death of the coral. And when coral systems collapse, entire marine ecosystems collapse. Fish loss habitat, food chains break, biodiversity reduces. This is not a local problem, this is ecosystem collapse. So remember carefully, coral bleaching is equals to system failure triggered by temperature. So let me take another example, that is GLOF. Now let's move to mountains, that is GLOF, glacial lake outburst flood. What is this phenomena? Let me simplify this step by step. Glaciers are melting. As they melt, water accumulates and form lakes. This is the phenomena. Now these lakes are not stable. They are held by weak natural barriers. So slowly pressure builds. Nothing happens immediately. Everything looks normal. And suddenly the barrier breaks. And the entire lake was massive water flow, floods, destruction, the downstream happen. This is not a sudden event. This is a delayed disaster because the system was unstable from the beginning here. We are not seeing a flood. We are seeing a time bomb explode. So you are seeing a time bomb explode. So remember very much care. GLOF is equal to hidden stability, hidden instability. It leads to sudden collapse. So wet bulb theory is human survival limit. Coral bleaching is ecosystem collapse. GLOF is delayed system explosion. So these are not isolated topics. These are examples of systems crossing limits, threshold. So you are not observing events. You are witnessing systems breakdown. So let's say take about real India link. So those are heat waves, landslides, urban floods, etc. Heat waves, let's take with heat waves. Every year temperature are rising, but the problem is not just rising temperature. It is how the body responds to it. When temperature increases, your body tries to cool itself through sweating. But when heat is combined with humidity, cooling fails. And suddenly what looked like just hot weather becomes life threatening. Heat wave is not about temperature, it is about the limit of human tolerance. That is why some years feel manageable and some years feel extreme because the threshold has been crossed. So remember, heat waves equal to temperature plus humidity that leads to survival risk. So this is the ecosystem fails, ecosystem limits. This is called survival threshold. Survival threshold. Let's say example, a question on temperature glacier ecosystem. First you have to think is a limit being crossed or not? That is the simple funda. So we are moving to system number 4, that is pollution systems. What is pollution systems? Pollution is not local. You have to understand this pitch very much careful and please observe this. Pollution is not local. It is systematic. It is systemic. Air flows, water flows, waste circulates, then pollution moves. Let me take one example here, that is airshed. Now let us understand one very important concept, that is airshed. Let me ask you something, when Delhi faces pollution, is Delhi the only problem? Most people think yes, but that is wrong. Pollution does not respect boundaries like political boundaries. It moves. Now observe this very much care. Punjab burns stubble, smoke rises into the air. Wind carries that smoke across regions, and finally Delhi suffers. So what is happening here? The source is one place and the impact is another place. The source is here Punjab, the impact is here Delhi. Source is not equal to impact always. That is called as airshed. It is a shared atmospheric system. So remember this clearly. You cannot solve Delhi pollution without solving root cause, that is Punjab emissions. So we are moving to next concept, that is EPR. What is EPR? Now let's move to responsibility. EPR means extended producer responsibility. Earlier, the system worked like this. You buy a product, you use it, you throw it away. You are responsible. But this model failed because waste kept increasing. So the system has changed. So the system changed here. Now responsibility shifts from consumer to producer. Earlier, the responsibility is consumer. Now shift to producer. The burden has moved upstream. Now the company that produces plastic is responsible for collecting and managing it. Now think carefully. This is not just waste management. This is system correction because the source of pollution is being made responsible. So remember, EPR equal to producer accountability for waste. That is EPR. Now let's go one step deeper. That is circular economy. Let me ask you something. What is waste? Most people will say something useless, but that thinking is wrong. Waste is not useless, it is misplaced. Let me explain very much clearly. Plastic, metal, electronic components, they are not useless materials, they are valuable, but they are in the wrong place. Instead of being reused, they are thrown away. So circular economy says do not discard, recycle, reuse, reintegrate. Waste is a resource in the wrong location. Airshed is means what? Pollution moves across regions. EPR responsibility shifts to producer. Circular economy, waste becomes a resource. So here pollution is not a local issue, it is a systemic flow problem. So moving to system number 5, that is biodiversity strategy. What is biodiversity? Let me ask you something very clear. Why do we protect species? Most students will say like this: to save animals. That is not wrong, but is incomplete, etc. etc. UPSC does not want a botanist, it wants a strategist. Now understood. Now understand the biggest mistake students make. They study biodiversity like this: species names, national parks, con- conservation lists, reports, etc. But UPSC is not asking names, it asking roles. The shift is clear. The shift is from memorization to understanding function is very much clear here. So now let me explain this with one example. Let's take mangroves. Most students think it is just a coastal tree, but look at its role. It absorbs carbon. It protects coastlines from storms. It filters water. Now think carefully, is this just a tree or is this infrastructure? You don't lose a tree, you lose a protection system. If mangroves disappear, carbon increases, coastal erosion increases. If mangroves disappear, what will happen? Carbon increases, coastal erosion increases, disaster vulnerability increases. So biodiversity is not decoration at all. It is a protection system. Now let's go into deeper. Indicator species. Some species behave like signals. These are called indicator species. If they are healthy, the ecosystem is stable. If they decline, something is wrong here or there. So this species is the signal. So that is why called as indicator species. Ecosystem is the story. Let's take example, if a marine species disappears, it is not about that species, it is about the ocean health. Now let's connect this a global policy 30 by 30. The idea is very simple here. What is 30 by 30? Protect 30% of land and oceans by 2030. But again, this is not just conservation. This is system stability planning. Because without diversity, climate systems fail, food systems weaken, ecosystems collapse. These types of things happen. So UPSC will not ask what is mangrove, what is mangrove or not. It will ask like this: what role does it play? Statements like biodiversity has only ecological value, species protection is only conservation. These are traps. So biodiversity is equal to function plus value plus survival, that equal to biodiversity. Let's say in the exam hall, if you see a question about species, what will you do? Don't think name, think role. What does it do? What systems does it support or not? And you will eliminate options. In this way, you have to identify the correct options. Mangroves as protection system, indicator species, warning system, 30 by 30 or 30 into 30 global system stability. So biodiversity is not about saving nature, it is about sustaining life systems. Sustaining what? Life systems. So what role does it play? Climate, finance, carbon, market, ecosystem, limits, pollution, system, biodiversity, value. This is the change happened. So let's bring everything together. Biodiversity, ecosystem, pollution, climate, carbon. This is how UPSC sees environment. UPSC is not testing what you know, it is testing how you think. Now think carefully. You keep collecting PDFs, confusion will increase because more information without structure creates noise. But if you understand systems, even unfamiliar questions also become predictable. Clarity beats content. Understand the system, trust the structure, and when you sit in the exam hall, the paper will not feel random anymore. Understand the system and rank will follow. So in this system, carbon, biodiversity, these five things we learned here. Few terms are also learned here. So for 2026 preliminary examination, these systems, five systems, and few terms, that is GST, etc., is most important for the upcoming examination. So you have to focus on these systems. These five systems have more or less 35 themes. So you have to focus on the entire topics. And all the best.